Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are learning how to convert fractions to decimal. Specifically, we'll be looking at the division method. Division method simply has to do with the long division. Without much ado or say, let's quickly look into it. So if you have a question in this form which says you have to convert 3 over 5 to decimal, convert 3 over 5 to decimal using the division method, what does it mean? So if you have 3 over 5, then you should note that it can be written as 3 divided by 5. You see, so the answer to 3 divided by 5 becomes your conversion. Hence, using our long division method or our division method, what do? We know the numerator becomes what? The dividend. So we put that here. And then our denominator, which is the 5, becomes our divisor. You see. So with our dividend and divisor, the quotient, which is the answer we'll get after the division, becomes our answer. So to divide in this form, we take the numbers one after the other. We ask ourselves, 5 divides 3 how many times? It can't divide it, so that is a 0. Then 5 times your 0 gives you what? 0. Then if we subtract, what do we have? We have a 3 at the end. Now with this 3 at the end, you always want to divide such that there will be a remainder of 0. But this 3 here serves as a remainder. Hence, you would want to continue. There is no number here we could have said, oh, we are bringing that number down to aid in the division. Hence, we are allowed to introduce a decimal point. And this decimal point allows us then to add a 0 to our remainder. With that, you ask yourself, 5 divides 30 how many times? 6 times. So 5 times 6 gives us a 30. You write that under. And then you do your subtraction, giving you a remainder of 0. Which implies that your 3 over 5 has become what? So that is 3 over 5 has then become what you have here, which is your 0.6. And that is your conversion. So this is just the application of long division. That is using your long division to what? Get the decimal forms of fractions. Let's look at some few more examples. Okay, so looking at this second question, it says you have to convert 7 over 4 to a decimal. Convert 7 over 4 to a decimal. And just as we did in our previous example, 7 over 4 can then be written as what? 7 divided by 4. You see, where 7 is the dividend and then 4 becomes the divisor. So in our long division symbol, we have what? 4 outside and then 7 inside. Hence, let's proceed with our division. So 4 divides 7 how many times? We are taking it one after the other. So 4 divides 7 just once. And then after your division, you multiply. So 4 times 1 gives us a 4. And then we do our subtraction. 7 minus 4 gives us a 3. You are then allowed to bring the next number. But in this case, there is no other number. Hence, you are allowed to introduce a decimal point, which then allows you to bring a 0 over here. Then you start the whole chain again. 4 divides a 30 how many times? That is a 7. And 4 times 7 gives us a 28. You do your subtraction once again, and then you have a remainder of what? 2. So with our remainder of 2, since there is no other digit here, this decimal point we have added once for all allows us to add 0 to any remainder that we have. So we can put a 0 here and then continue with our division. 20 divided by 4 gives us a 5. And 4 times 5 in 10 gives us a 20. If you have to subtract, what do we have? We have no remainder. So our quotient now becomes the answer that we need. That is 1.75. And that is the decimal form of the fraction 7/4. Now, this whole idea brings us to what we call terminating decimal and then recurring decimal. There are two types of decimals you get anytime you get involved with these divisions. So what do we mean by terminating or recurring decimal? When we talk of terminating decimals, you know who a terminator is. So the terminating decimal, it ends. Whenever you are doing your division, the division ends at a point, such as all that we've done in these examples. You see that it has actually ended. There is no other number for us to proceed with. Hence, we say those decimals terminate, terminating decimals. On the other hand, if you have a decimal that is recurring, it is repeating over and over again. There are some divisions that you do, you get 0.333, and you see that it's still continuous. The same number repeating itself in a pattern. It recurs, so we call that a recurring decimal. And most of the times, if you get such a decimal, all you do is you write at least one of the repetition, and then you place a bar over it. Let's solve some examples so you actually understand what I'm talking about. For now, we have done all those that has to do with terminating decimals. So let's take some examples that will lead us to recurring decimals. So under recurring decimal, the first one we are going to look at is we have to convert 1/3 to a decimal. So you use the same procedure. And you know, this time around, let's quickly go straight to the point. So 1/3, we have 3 outside, that is our divisor, and then we have our 1 here. 3 divides 1, 0. Hence you have 3 times 0 giving you what? 0. If you subtract, you have a remainder of what? 1. Now we would want to continue with, so that there will be no remainder. Hence we introduce our decimal point, which allows us to put a 0 here. 3 then divides your 10 3 times. And 3 times 3 gives us a 9. If we have to subtract 9 from 10, we have a remainder of 1. Because of this decimal point, we are allowed to introduce another 0. And you realize that it will be going over and over and over. This amount 3 into 10, 3 times again. 3 times this 3 gives us a 9. If you have to subtract, you have a remainder of 1. This decimal point allows us to introduce another 0. And it goes on and on and on. You see, so there is no need continuing. Since we have realized that 3 is going to repeat over and over, all we need to do is we say our 1/3 is then equal to a 0.3 with this bar on top, indicating that there's 3 is recurring. So it is read as 0.3 recurring. 0.3 what? Recurring. Because the 3 is repeating over and over again. It is not always that it's just one number that will recur. Sometimes 2 or more numbers can also recur. With that, let's solve this example and see. So with respect to that, let's look at this last example here, which is convert 3 whole number 2/11 to a decimal. 2 whole number 3/11. Now there are two ways you can do it when it comes to mixed fraction. Because you know the whole number is always constant, you can say 3 point, then you convert the 2/11 to the decimal. Easy. Or you can change everything to an improper fraction, and then you proceed for there. Let's do that with the liter. That is 3 whole number 2/11. That becomes 35/11. That in mind, converting 35/11 into decimal, we have a 11 as the divisor, then the 35 comes in as our dividend. 11 into 30, first of all, 11 into 3, 0. So 11 times 0 gives us a 0, and then if we subtract, you have a 3. With that, since there is another number here, we can introduce that number, which is our 5, and then continue our division again. So 11 into 35, 3 times. 11 times 3 gives us a 33. We have to subtract. We have a remainder of what? 2. Now, since there's no other number to bring down, we are allowed to introduce a decimal point. And it is with this decimal point that we are allowed to bring a 0. 11 into 20 once. 11, 1, 11. And if you have to subtract that, we have what? 9. Introducing another 0. 11 into 90, how many times? We have 8. And 11, 8, 88. If you have to subtract, you have a remainder of what? 2. You see? So with a remainder of 2, we can still proceed. Because we already have a decimal, we just put our 0 and continue again. 11 into 20, how many times? Just 1. 11, 1, 11. If you have to subtract, we get 9. Then introducing another 0 to 8, we then have what? 11 dividing 90. 11 divides 90 8 times. 11, 8, 88. And you realize that it continues over and over again. So what you see is that the 18 will keep repeating indefinitely. You see, so we can then conclude that our 3 whole number 2 over 11 is actually 3.18. Then the bar is on both the 1 and then the 8 because they are both repeated. You see, so this is basically how we convert fractions to decimal. You don't have a problem if your long division is okay. But if not, you can check my playlist on long division so that if there's anything you don't understand, you'll be clarified on those lessons as well. This is how beyond numbers where we learn maths the easy way. As usual, I'll leave you with some exercises so you try on your own. So here are just 5 questions you can try on your own to test your understanding. They are based on all that we have done in this lesson. If there's any clarification you need, you can always let me know in the comment section, and in due time I'll address that for you. If this is your first time on this channel and you think this would be of help to you, you can always choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. Stay safe and bye for now.